Okay, now we're going to talk about multiplication of fractions using array, also called as the square model. Okay, I've set up a large template because we're talking about 2 1/4. So I'm just going to draw a line right here to represent 1 whole, 2 wholes, 3 wholes, because I need to go above 2. After students have worked with fraction models before they get to the mixed numbers, then they will see the progression of the model getting bigger. Okay, you shouldn't get to this model unless they practice the other ones. Alright, so what I'm going to do is I'm not going to cut this into fourths because we're talking about 2 1/4. So I'm going to cut my 1 unit into 4, my second unit into 4, and then my third unit into 4. In a minute, I'm going to shade 2 1/4. Okay, so now this is going to represent my 2/3. Remember, area is, we're talking about covering space, square units. Okay, so I want to take this and I'm going to cut him into thirds. Well, there's 1, there's 2, and then there's 3/3, which we know is equivalent to our 1 whole. Alright, so what we're going to do is we're going to shade 2/3 of this giant whole with 1 color. And when we're talking about multiplying, we're talking about pieces that are going to be covered. Oops, I shaded too much. Okay, so I'm going to stop because I only need to shade 2 out of 3. Over here, I'm going to use an orange and I'm going to simply shade 2 1/4. That's a whole. That's my second whole, and I want to shade 1/4. Okay, now remember that we're going to examine how many squares make up our whole unit, and I should have accidentally shaded over here. So my overlap lies right in here. This is where everything's overlapped. Okay, but we're going to focus in on our whole unit, which is there and all the way over here. Whole unit is 1. So how many squares make up a whole unit? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares equals the unit, also known as the whole. It's the same concept we've been using for adding, subtracting, multiplying, and we'll use it again with division. Okay, so now we're going to come over here and we're going to see, well, it takes 12 squares to make 1 whole unit. So what I'm going to do is I'm going to count them off, and when I get to 12, I'm going to make that a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares makes 1 whole. 1, 2, 3, 4, 5, 6. Well, I have 1 and 6 out of 12. Why 12? Because remember, our whole unit, which would be 4/4 and 3/3, was 12 squares. Well, I had a whole and 6 squares left over. And some kids will be very quick to say that's equivalent to 1 and 1/2 because 6 is half of 12. Now, the standard algorithm requires students, I'm sorry you guys, I keep making silly mistakes, 1/2. Alright, now the standard algorithm tells students that you need to take a mixed fraction, 2 1/4, and change it to an improper fraction by saying the denominator times the whole, which is 8, Add the numerator, which is 9/4. Now you can take 9/4 and multiply it by 2/3. 9 times 2 is 18, and 4 times 3 is 12. There's our 12 again. That's our whole units. I could have gone back up here to the model and counted all of these without focusing on 12 being the whole unit, and simply wrote that as 18/12 and got the same answer as the algorithm. But now students can simply see that that's not just 18/12, but that's 1 whole and 6 squares left over. To finish off the algorithm, students would also have to say 18 divided by 12. 12 being the divisor and 18 the dividend. Then they have to solve a division problem by saying 12 goes into 18 how many times? 1 whole. Out of the 18, if I take 12 out, I'm left with 6, which now students sometimes write it as R6, but we know that that's the same as 1 and 6/12. Up here, the pictorial model helps bridge students with understanding of what remainders are. Remainders are left over. Well, that's 6 out of what? What size pieces? What's our divisor? 12.